When solving a linear constant coefficient differential equation, we assume a solution in the form of yx equals e to the rx. If we differentiate that once, you're going to get y dash x equals r to the erx. And differentiating that twice, you're going to get r squared e to the rx. We can now take each of these and substitute in to the left hand side. We're going to ignore the right hand side for now. So you're going to get r squared e to the rx minus 4 e to the rx. I'm going to make it equal to 0. Let's now substitute out the erx. So you're going to get e to the rx, r squared minus 4 equals 0. If you divide both sides by e to the rx, that's going to disappear, and now you have a quadratic that you can solve. So that's obviously going to be r equals plus or minus 2. So the complementary or homogeneous solution is yh x equals c1 e to the 2x plus c2 e to the minus 2x. You substitute in your roots, which are distinct and real, into here. So you have these two constants, and then whatever the numbers, let's say they're 1 and 3, you put 1 and 3 here. 1 and minus 3, 1 and minus 3, that's where they go. So now let's start cracking on the right hand side. So for the right hand side, we have xex. So the general formula for a non-homogeneous term with xex is going to be ypx equals ax plus b to the ex. And for cos 2x, we'll mark that as yp1, and let's do yp2x. It's going to be, which is cos, which is obviously trig, it's going to be c cos 2x plus d sine 2x. So we've kind of got our bits to work with, but we need to do now a lot of stuff. So let's first differentiate. Let's first focus on the ex term. So let's differentiate this once. So yp11 differentiated is going to be ax plus a plus b to the ex. And let's differentiate that again. So you're going to get ax plus 2a plus b to the ex. And now we can plug this into the equation. So you're going to get, if I can fit this in, you're going to get ax plus 2a plus b e to the x minus 4 ax plus b to the ex. Is that right? Yeah, that's about right. We're now going to simplify this. So I'm going to group together all my a terms and my b terms. So we should be able to get something like minus 3a x plus 2a minus 3b e to the x, which is x ex. So that's equal to the right-hand term. We're going to ignore the cos for now. So the left-hand term side is equal to just this. If we match coefficients, so we obviously have our a terms and b terms, a terms next to x's, and then our b terms and a terms which are not, so they are just regarded as constants. So we're going to get minus 3a equals 1. So a is going to equal minus a third. And then obviously now if we equate anything to do with the b terms, we're going to get 2a minus 3b, which equals 0. And so if we now know our a term, we can substitute this in here and then rearrange to find the solution. So b is going to equal minus 2 over 9. Tiny little bit at the bottom there, but I think I can fit it in. yp1x is here. We now know our a and b terms, so we can substitute those in. Minus a third x minus 2 over 9 e to the x. We're not done just yet. We're going to tackle yp2, which is here. And so if we get yp2, I'm going to write x, which equals c cos 2x plus d sine 2x. Same as we did last time. We're going to differentiate this once. So this is going to be minus 2c sine 2x plus 2d cos 2x. And now let's differentiate that again. So you can get minus 4c cos 2x minus 4d sine 2x. Everything to do with partial differentiation and with equating coefficients. I have specific videos on them on my channel, so you can go and watch them, but I'm obviously not going to unpack them fully here. We're focusing on solving the linear ODE. Let's now sub these into this equation. So you're going to get minus 4c cos 2x minus 4d sine 2x minus 4, and then there's some brackets, and that's going to be c cos 2x plus d sine 2x, and obviously all of this, so I've plugged in that and that into here and here, is going to be equal to just this, so the cos 2x. So I'm going to simplify this all up, so that's going to become minus 8c cos 2x minus 8d sine 2x, which equals the right hand side, which is cos 2x. Again, like we did with the exponential term, we're going to equate coefficients. So we can look at everything to do with our c's, which is pretty simple. So we've got minus 8c, which equals 1. So therefore, c would equal minus 8th. And then minus 8d, obviously there is no sine 2x's here. They were equatable in the other one. So that's going to be 0. So therefore, d is obviously 0 when you divide both sides by minus 8. We can now plug this into here. So now yp2x is going to be minus an 8th cos 2x, and obviously d is 0, so that whole thing is 0. We now know that yx is yhx plus ypx, even though I appreciate that p is made up of yp1 and yp2, obviously. So now let's bring it all together. So we're going to get c1 e2x plus c2 e minus 2x plus minus a third x minus 2 over 9 e to the x minus 1 over 8 cos 2x. That is the general solution. If your question gives you, let's say, y naught equals 1 or y differentiated 1 equals 4, you take these values and you plug them in, and you'll be able to find out all the constant values too. So then those have also been eliminated. Hopefully that makes some sense.